Hi, this video is a quick recap of 7.4 in case you missed it. And we're just going to go over some of the highlights. So take a look at page 322, example 1. Here you have a problem, and this is your resultant vector, and it has and it's indicating it's a vector. And this is actually the point at which the vector ends. At 3, -2. This is what we call position vector. So this vector is basically, if we could draw it real quick here, this distance right here is 3. This is your x, and this is your y, which would be a -2. So this would be the point 3, -2. So the vector is going down this way. And a vector has a initial point and then an ending point, and this is the ending point. So what we wanted to do was find the magnitude and the direction of this vector. We could say it goes down is the direction, but we want to know what actually this angle is, theta, and we actually want to know the magnitude. What is the when we're showing magnitude, we usually put it in something that looks like an absolute value like that. Okay, so to find the magnitude is really, the Pythagorean theorem. This distance right here is 3, right? This distance right here is a -2. So the magnitude of this vector is simply the square root of x squared plus y squared, which is, well, we just write it down. So the magnitude is the square root of x squared, which is 3 squared, or 9, plus a -2 squared, or 4. Magnitude is square root of 9 plus 4. So the magnitude is square root of 13. So there's your magnitude. The next thing we want to do is kind of look at what's the angle of this thing. So to find the angle, we get theta, we have the opposite, we have the adjacent. So theta is simply tangent theta is the opposite, -2, over the adjacent 3. Okay, pretty easy. So theta is going to equal the second tan, inverse tan, bring it over, of -2 over 3. So I don't know if I have that on my calculator on this chart, -2 over 3. So I'm going to have to go to my calculator, and let's see what that is. Second tan, -2 divided by 3 is a -33.6, or 7. Let's round it off to 7. -33.7. A lot of times, however, we want the angle as being positive, so we're going to add 360 to that to get a positive angle, plus 360. So that's 326.3 if you want to go it, or you can just round it off to 326. Well, we're right at this 326.3 degrees. So that's your angle. So there we have it. We have the magnitude and we have the angle. So here's your magnitude and here's your angle. Okay, so that's all there was to it. I mean, you can make it all complicated, but that's basically using the Pythagorean theorem, and then you're using it, providing this forms a right angle. Okay. Now, we know, what else do we know? We know, let's see, a couple of things we know. We know the sine of an angle, sine of theta is equal to what? say this was A, and this was B. Let's see, how can we write this? A and B. Um, the sine is equal to the adjacent, which is, we call this side, they're usually calling this side B, and this is side A, okay? So in the book, they're referring to this as B. So what is the sine? The sine is this over the magnitude, U. Okay, but what if I wanted to find B? And I don't want to, I just want to find the side. I'm not looking for this. So I could just rewrite this, B is equal to what? The sine of theta times the magnitude, or the hypotenuse, kind of like the hypotenuse times the sine of theta. You can think of it that way, or you can think of this as the magnitude. This distance right here is the magnitude because it's a vector. Likewise, if we had the cosine of theta, cosine theta equals A over U. So we could rewrite that as A is equal to the magnitude times the cosine of theta. So sometimes it's easier to have it in this form than if we were looking for the angle, we'd probably want it in this form. But if we were looking for the side, it's probably easier to do it that way. So then we could put these into a little formula. Usually we write A comma B, or we could write the magnitude times the cosine of theta, comma, the magnitude times the sine. And remember when we were looking at the unit circle, we always put the cosine and then the sine. So kind of like the same thing we were doing there. So we can sometimes write it that way too, if we want to write them as a vector. So if we know this, we want to find this, we can just kind of list it like that, and we can find them really easy. So let me give you an example on example, let's take a look at example 3. Well, let's look at example 2. All right, using this information, let me put this back up here. You probably couldn't see it too well. Okay, so that's how they got this. We usually list it as A and B, but now we're going to list it as A cosine theta B. So let's look at example 2 real fast here. We've got this drawing here, and they've got this distance right here. This is A, this is B. This is our angle 41.7. And we know this magnitude right here, call it U if you want, is 25. Okay, so it says use the two formulas in the box, let's see, to calculate A and B. Okay, so we want to write it as A and B. Let's take this little formula right here, we'll put it up here. Let's see if we can fit all this on the paper. So I want to find A. Okay, all I got to do is take my magnitude, which is 25, times the cosine of theta, which is 41.7. And I can look that up on my calculator. And this will give me the value for A. So 25 times, just a little faster way of doing it, 25 times the cosine of 41.7 is about 18.7. We're rounded off. Okay. And then I want to find B. So it's going to be 25 times the sine of 41.7. So if I'm using my calculator, all I got to do is go back up here, do a slight adjustment, put it over the cosine, change that to sine, and hit equal 16.6. So now I can write it, instead of writing it this way, I can just write it as A 18.7, comma 16.6. And that's all there was to it. Okay, there's my A and B, and that's the resultant That's where the vector ends up at. Okay, those are horizontal and the vertical components of the vector. Okay, what if I had one example 3? I had it written this way. They said, okay, this could be any letter, is equal to 5 cosine 60, comma, 5 sine 60. I could use my calculator, but they want an exact answer. So I can look up the cosine of 60. This would be simply 5 times the cosine of 60, which is a half, comma, 5 times the sine of 60, which is radical 3 over 2. And I can get an exact answer if they want on this one. It's just going to be 5 halves, comma, 5 radical 3 over 2. So I just look up the cosine of 60, 0.5. We could put it also in decimal form, but they want an exact answer on this particular one. So that's all you're doing right there is you're just, if you have it in this form where it's written with the cosine, you can just convert it back over. And this one a little bit harder because we had to, do a little manipulation. Okay, let's look at example 4 here. Now here, this one's a little tougher because we don't really have a right triangle. So let's take a look at that problem. Do this on another little sheet of paper and we can show you real fast here. Let me see if I got a better pen to I think it'll show up enough with this. Okay, so what happened is on this particular drawing, there's two forces and they're going in opposite directions. So you got this force over here, and this is 15 newtons or whatever it is. Sometimes we do this in physics, and this happens to be 22 newtons. And we have this angle right here, which is 100. Okay, so there's a little rule that says we can do a quadrilateral to find the resultant. We want the resultant force, which would give us the magnitude of this of these two forces. And so we kind of sketch a little drawing here that makes it kind of a parallelogram. On a parallelogram, if you remember, the two sides are equal here, and then these two sides are not equal, but they are equal, but they're also parallel. These two sides are equal and parallel. So this side would be 22 again. This one would be 15. The resultant force is a force that's coming through here, hitting right at that point. Now, the problem is, in order to find this, call this V or whatever, you give it any kind of name, to find this force here, we don't have a right angle. See, this is not a right triangle. Plus, we don't even know these angles here. To do this, if we knew these two sides and the angle between them, we could use the law of cosines, but we don't have this angle. So what we're going to do is we can project down that this distance is also 100. So how can I find this angle? Well, in a parallelogram or any quadrilateral, they're going to add up the angles, all add up to 360. You already have 100 and 100, so that's 200. So there's 160 degrees left to share between these two angles. So if we split that in half, that's 80 degrees. So this angle would have to be 80 degrees, and this would have to be 80 degrees. Now, to find this distance, we can use the law of cosines. This distance right here, called V, is equal to 1 of the sides squared, 22 squared, plus 15 squared, plus 2 times 22 times 15, times the cosine that's opposite this angle. I mean, the cosine that's opposite this side. The angle is opposite the side, so the cosine of 80 degrees. So if you stick this in your calculator, you square this, you multiply this, you multiply times the cosine of 80, you end up, but this was V squared. So you end up with an answer like this, 595, save a little bit of work. However, that's squared. So now we got to take the square root of both sides to find what the magnitude is. And if you take the square root of that, you come up with 24. You know, and so the answer to this is the magnitude of this, the resultant, this is called the resultant magnitude is 24 newtons. This force acting this way, this force acting this way will result in a force of 24 newtons. That's basically it. Okay, the rest of the chapter is pretty easy. Okay, that's probably the hardest problem, and you just have to remember law of cosines. Try to find the angle that's opposite this. Now, if it was a right triangle, it would be a lot easier because then you could just use, tangent or something like that, or sine or whatever, But on this one, because it's not a right angle, it's 80 degrees, we have to use the law of cosines. Okay, a couple other things. Say you're going to add two vectors together, AB plus CD. To add these together, all you have to do is add the first term to the first term, A plus C, excuse me, and then B plus D. And then you get a different vector. Okay, so I'm going to go through these real quick and kind of show you using some numbers. Say we had 2, negative 2, 1, and 4, 3. This is U and this is V. And they say, okay, figure out U plus V. Okay, so they just want to add 2 plus 4 and 3 plus 1. Just that easy. 1 plus 3, 3 plus 1. So your resultant is your new vector is going to be 6, 4. Just that easy. First plus first, last plus last. Okay, how about negative 2u? Okay, that means we're going to take our u vector and multiply everything, kind of distribute it. That's all. It means just distribute this in. This would be negative 4, this would be negative 2, and there's your new vector. Just that easy. Okay, the third one says, how about if we had something more complicated? We had 3u plus 2v minus 2v. Okay, so we're going to take the first vector, u, multiply by 3, and the second vector minus 2 times the second vector, which is, what was the second vector, 4, 3. This vector right here. There's u. Here's u, here's v. So this would be 6, 3 minus, well, let's put plus a negative 8, change it to addition, negative 6. Let's do it that way. So this is going to be 6 plus negative 8. That's going to be negative 2. Last plus last, 3 plus negative 6. That'll be negative 3. And there's my new vector. Did I goof up? Must have made a mistake here. Let's see. Let me write down my vectors. I multiply by negative 2. Negative 8. Oh, this was a negative 2. I didn't even notice that. This on the original one, this was a negative 2. I'm sorry. So this is going to be off a little bit. This should have been negative 2 plus 4. Negative 2 plus 4 would be 2. So this should have been 2, 4. And this was a negative 2, which gave me a positive 4. And so now I have a negative 3 times a negative 2 would be a negative 6, negative 8, negative 14. I just copied the problem wrong. Okay. Don't worry about this stuff about unit vectors. Just ignore that. And then the dot product is pretty easy too. If you have a problem, let's try a dot product. Say we have 2, 3. times 4, -1. This is called dot product. I guess because there's kind of a dot in between them. I don't know. All you do is multiply the first times the first and the last times the last. That's all there is to the dot product. And then you add them together. One last thing. So you're going to multiply them and then you're going to add them. I always forget the adding part. There's my answer, 5. And you don't have to put it inside there. You can just write it as 5. So the dot product of these two forces is 5. Try another one just to make sure. 6, 4 times -2, 3. Okay. 6 times -2, -12, comma. 4 times 3, +12. Add them together, nothing, 0. Okay. Very last problem. Let's try that one. Very last problem. Okay. It says find the angle between two things. Kind of like this problem right here, where we're trying to find the angle between two numbers. Like this problem right up here, where we were trying to find this angle, but unfortunately we have the sides, but we don't have much more information. So they have a little formula to help us out. The cosine of that angle is equal to the vector u times v over, remember this is your resultant, or your I shouldn't say your resultant, but this is your magnitude of the vector. This is basically c if you were using the Pythagorean theorem, and this is v, okay, same thing, c. These are your hypotenuse. So here we're going to use the dot product. So in this problem, they're saying u is 3, 4, and v is 2, 1. We have these two vectors, and they end up, this is the points they end up at, maybe something like this. And we're trying to figure out, we got this distance, we got this distance, we want this angle between them. So we're using this kind of a formula for this. So first thing we want to do is the dot product of these, So let's see what that would give us. This would be 3, 4, and times 2, 1. So the dot product would be 3 times 2 is 6. 4 times 1 is 4. And then remember, we add those together. So that gives me a total of 10. Okay, now on the bottom, what we want to do is actually use the Pythagorean theorem. So we're going to use these two numbers. This is really x and this is y. So to find this u is equal to the square root of 3 squared plus 4 squared. U is equal to the square root of 9 plus 16. U is equal to 25. So this u right here is the square root of 25, excuse me, which is 5. U is 5 times, well, I just put the 5 there, times, now I want to do the other one, V. Let's just do it down here. I think I have enough room. V is 2 and 1. So this would be 2 squared plus 1 squared. This is 4 plus 1, square root of 5. So this would give me 5 square root of 5. Then we could simplify that a little bit. 5 goes into 10 too. So we could leave it as 2 over the square root of 5. That would give us the cosine of theta. but I want to know what theta is. Okay, so theta is the arc cosine or inverse cosine of 2 divided by the square root of 5. So let's put that on our calculator. Here we go. Clear it out. So I've got, let's see, 2 divided by, let's start over again, second cosine. I'm trying to rush this video. 2 divided by second square root, second x squared 5. I want to put that in a parentheses like this, and I want to put another parentheses to end a big mess, equals 26.5 degrees. That's what I come up with, 26.57. They carried out quite a few. I usually go on just one decimal point. So I would usually call this 26.6 degrees. So I wanted to find the actual angle. Theta is. So it's just a matter of doing a dot product on the top and then using this as x and y, and u equals x squared plus y squared. It's almost like the Pythagorean theorem, c squared equals a squared plus b squared, kind of like that. Call this a and this b. A squared plus b squared equals c squared, So you're just using the Pythagorean theorem here. Calculating the one, calculating the other, then times them together. And here I decided, I could have just put it in like that, but I decided I would reduce this a little bit. Cosine theta equals this. Bring the theta over to the other side. The cosine over to the other side. Arc cosine or inverse cosine. In other words, you're trying to find the angle. So whenever you're looking for the angle, you just divide. So I hope this helps. Try some of those problems and see what you can do.